Right. So if you remember on this one, I've got an a times c, right? And then I find the factors of a times c that add up to b, right? So f1 times f2 equals ac, and f1 plus f2 equals b, right? David, that kind of ringing a bell for you? Huh? Kind of. What did I do? I looked at where my limit was going, and I divided by that piece, either long division or synthetic division, and that helps me factor as well, right? But you don't have to do that. You don't have to do that, right? But doing synthetic division, doing long division, that all should be in your wheelhouse, right? You did it all in pre-cal, so let's look at a problem, David, okay? So I'm going to our Blackboard page. It takes me forever to get there. Anybody ever drive in Virginia? You know how long those red lights are in Virginia? You know, it's like 2 or 3 minutes you're stopped at a red light. Same thing here. I'm just trying to use my time as best as I can. It's not a good idea to bring a book while you're driving, but sometimes we have to do what we have to do. Here we go, Calculus 9 a.m. Past exams and etc. Let's go to chapter 2. This is an exam. I'm just going to look at it. I'm going to take a look at a limit here, hoping I got one I can factor. I do. I can factor. So number 1, right? You can tell it's factoring, yes? Polynomial over polynomial, I'm looking for factoring. I don't see fractions within fractions, correct? I don't see a square root. So really my only hope here is that I can factor this, right? All right, you with me? Let's do this one. Let me just get a real quick picture of it because I'm going to forget. Godzilla. So the limit is x goes to -2 of x squared minus 4 over x cubed plus 8. David, yes, you're with me? Good. I like to, because I don't want to, I'm lazy. I'm a lazy man. Sometimes I'll sit down on the sofa to watch TV and the remote control will be over on the other chair and forget it. I just sit there anyway. I don't bother. I'm lazy. But I like to call this function star or asterisk or whatever to see if I can manipulate it, because I've already plugged in my -2 and I got 0 over 0, right? Is that true? That's a plus 8, right? Yes, I got 0 over 0 when I plug in the -2. So I know I have to try and factor this. The top one is, I remember that one, really easy, right? But the bottom one is not so easy to factor. That's the difference of cubes. Again, remember, you're going to have a formula sheet. Yes, remember I said that? And you should be building it as we go. So you can have the formula for a, right? You could have that formula on there for a cubed plus or minus b cubed, which is a plus or minus b, a squared minus plus ab plus b squared, right? That's the formula we learned in Algebra 2. You can have that on there. I'm fine with that. I think it's easier just to synthetic or long divide here. So what issue do I have with this -2? Where's the issue in here that I have with the -2? Yeah. Yes, it makes the denominator 0. What part of the numerator does it make 0? The x plus 2, right? So I'm thinking, because I know how limits are working, I want things to cancel that are giving me trouble. I'm thinking this is going to be an x plus 2 times something, right? And so I've got 3 ways to get it. I could either have the formula memorized, I can synthetic divide, I can long divide. David, which one do you want me to do? Long divide, nice. I'm going to go x plus 2 into 1x cubed plus 0x squared plus 0x squared plus 8. What's my first question? How many times does x go into x cubed? And the answer is x squared. David, don't let me go too fast. How are we doing? Good. I'm going to come back and multiply. I get x cubed plus 2x squared. I change my signs and add. Just like we did in long division in 4th grade. So now I need a negative 2x. Change my signs and add. And now I need a 4. Yep. Where are you? (2x squared minus a minus 2x squared). So change your signs and add. Right, that first term always drops out. First term always drops out. That's why in synthetic division we just bring that first term down. Right? If you think about it, in synthetic, you don't have to change the signs and add. You just have to add. Right? So this long division is not calculus. This is something you should have known already. If not, go back and learn it. Organic Chem Tutoring Guide, Khan Academy, Nancy Pye from MIT. Oh, the one here, because I'm using 8x cubed plus 8. There's an x squared term there, but it's still by the coefficient of 0. Right? Isn't this gone and this gone? It's really x cubed plus 8. But I put the placeholders in there because, right, when I'm long dividing, I put hundreds, tens, and ones. Right? Yes, David? Good. So now we're ready. We're going to go back and get our replacement function. We know this guy is x squared minus 2x plus 4. These will cancel. So I get an x minus 2 over x squared minus 2x plus 4. There's my replacement function. Can I plug in the negative 2 here directly? Yes. So we're doing the limit as x goes to negative 2 of that asterisk. And so I got negative 2 minus 2, negative 2 squared, minus 2 times negative 2, plus 4. Notice once I plug in the numbers in, my limit notation is gone, right? I'm already at the wall, or I'm already at the height. It just could be cleaned up a little bit. What is 4 plus 4 plus 4? That's 12. So minus 1/3. How we doing? I got 3 people with feeling good about it. Yes. Sheila. Yes. Yes.
Like I get to this point and then I'm like, oh, it's still like a quick that and that. Like I sometimes I just don't want to stop.
Yeah, I get that. And a good thing to do is to start using the Desmos as your graphing, your visual part of it. So like if you thought you could so first of all, if you can get to here, you can compare the original function with the replacement function. They should overlap completely, right? And then if you start working on this, well, you better start, well, it's not right to do that, but you should put that in Desmos and see it's different and know, whoa, wait a minute, I don't do that. So the question is, you try and do the limit originally and you get a 0 over 0. Then you try and get a replacement function and then you get a number. oh, you're going to think that the number is right. As long as you keep getting a 0 over 0, you must keep doing something. When you don't get the 0 over 0 anymore, you're there. So that will help too. And remember, we could get this answer before we even do the problem, right? We can go to Desmos right away and do a numeric limit. Do you want to see that again? During a quiz, during a test. Yeah, so practice with it. I usually teach with the TI 83 or 84, but it's such a dinosaur. It's like a flip phone, basically. So if I can use Desmos, since we're in the computer room, I'm going to use Desmos. So I'm going to go right away to this original function. I can call it f of x. I can call it y. Remind me, x squared minus 4. Is that right? X squared minus 4 all over x cubed plus 8, right? And I already got an answer of, help me, 0.33, negative 0.3 forever, right? So I can start doing this. I hit the gear button, I hit the table button, and I'm going to negative 2, right? So if I graph this, I'm going to see, I don't care about two sides. I'm going to see a nice smooth function, right? So right there, right? And I'm interested in that negative 2, correct? So I like to type in x equals negative 2 so I can see so I can already see that I'm going to get a negative result, right? I'm going to get a negative height at x is negative 2. You with me? Yep. So I'll just work one side. So I'll say negative 2.1, right? I'm getting really close to negative 2. So negative 2.01, right? And you can see it's building dots there. You see how it's building dots? And then negative 2.001. And you can already see that I'm definitely getting to a negative, and I think I'm getting to negative 3 repeating, right? I can just go crazy for a second. Negative 2.00000. Right? Once I kind of get an instinct, I can just kind of cheat it and see if it gets there. Right? So I already know the answer is negative 1/3. Right? So that's going to help me too. It's always nice when you know the answer. Right? When you know what's coming, it's easier to deal with. Anything else? Yes. Go ahead. X as your x goes to c, right? As x goes to c, the height is going somewhere to L, right?
So then, but in this case, you figure
Yes. Yeah. So, but be careful what you're saying. The limit is a y value, right? And the c is an x value. So I'm walking underneath my curve, right? I'm walking on the x-axis, right? And I'm walking toward negative 2. And I'm wondering, if I was walking on the hill, what would the y value be? What height am I walking up to? So my shadow on the ground is going to negative 2, right? But my height is going to L. I don't know where. Right? That makes sense? All right. So you've got lots to do. You can be working on, what can we be working on? We could be working on the limits in WebAssign. Right, so that's homework 001 to 003. That is not being graded. You may do that any way you want, as messy as you want, right? as many times as you want. When you're in doubt, send me a quick email. If my girlfriend's not in the room, I can answer quickly. If she's there and she says, "Are you working?" We are doing chapter 2 review. Number 2. And we are doing chapter 2 quizzes. Anyone that looks like what we've been doing with a conjugate, with a polynomial, with fractions within fractions, right? And we're reading 2.1 to 2.3. I think I said 2.4, but not ready for 2.4 yet. In 2.1, I like numbers. I'll tell you in a second. 2.2, I like numbers. 2.3, I like numbers. I'm going to tell you in a second. Yes? Say it one more time. No, you can use anything you want. And especially because I don't want you emailing me from WebAssign. If you're going to email me directly. Again, I don't care what you use, but don't email me out of WebAssign. Don't say, "Hey, how do I do this in WebAssign?" Don't say, "Ask my professor in through WebAssign." Don't use that. Okay? I told you I'm ADD, right? But and then I realized later that that's a plus in math. Get it? ADD plus. I am seriously. So don't try not to be offended by me. But if I can't laugh at something, I have trouble. So we're definitely going to use Desmos today, so make sure you're signed in, okay? I just want to tell you some problems that you can start trying in the textbook, yes? The answers are in the back of the book. I'll show you where they are if you want, okay? So the answers are in the appendices. I had my appendix removed, so I have no answers, but where the heck are they? Nice for them to put a title on here. Oh, there it is. Sorry, appendices. Answers is Appendix J. Where the heck is Appendix J? It goes up to I. Come on. What a ripoff. It's not there, I'll tell you that. I'll get you answers, okay? They're not there. I don't know why. It's not J. What is it? I know that, but it says J here in the. It says answers to odds in Appendix J. In the old book, it was there, so I'll figure it out, okay? I will post it on Blackboard, and so that way you can be checking answers. Anyway, in chapter 2, in 2.1, I like all of the problems. No, that's not true. I like 1 through 9. All of them are fine, but 1 through 9 sounds better, right? You'll be able to do that today. You'll understand how to do those problems today. In 2.2, you see we're doing graphical limits here, sometimes numeric limits. Sometimes you can actually do them algebraically, but I guess like number, can you even see that at all? Number, no, they're not real. Number 30 is maybe the only one you could do right now, but that's fine. But they're asking you to do a table, so numeric limits there. So I like up to 33. If you look at the homework I assigned last semester, I assigned one problem from 2.1, and I think 3 problems from 2.3, nothing from 2.2, because it's graphical. I'm not going to ask you graphical on a test or a quiz, but you're going to be able to double check yourself, right? So 2.3, I like. Up to 35. So there's more for you to do. Believe me, you're never going to run out of things to do. But you've got to be practicing intelligently. You can't do 10 problems, look in the back of the book and realize you got them all wrong. Wasted all that time. You do one problem, looking at the answer, checking it with Desmos, saying, great, I get it, I'm the best in the world. Or if you got it wrong, you're trying it again, and then you're reaching out for help. Okay? So if you're stuck on the first problem and you reach out for help, go look at another class. Go make dinner for the family, et cetera, yes? Do something else. Don't sit there and be miserable. Ask for help. Okay? So you've got lots to do. Now, if you look at my old quizzes and my old test review, step 2 review, it's got all the answers. So that way, if you're stuck, you can say, hey, let me just peek at the answer and see what he did first, right? And then take that starting hint, and then don't look at anything else and try the problem, right? Oh, I got a prime factor. Oh, you got an LCD here. How the hell did you get the LCD? What's my note say? Oh, I didn't take notes. Oh, well, I'll go LCD, right? So, but got to be working smart. All right, let's talk about when limits fail to exist, okay? And then we're going to go on to section 2.1. I typically don't ask this on a test or a quiz, okay? So, but it's still important for us to really understand limits to know when they don't exist as well. So L does not exist. That's supposed to be an E. So like the limit is x goes to 0 of 1 over x does not exist. We don't say equals does not exist. The WebAssign has got a big mistake in that. When I say equals, it should be a number, okay? Or an equivalent fraction. Function. When I say it does not exist, it means it's not a number at all, right? So there's 3 cases. Question?
I was just going to say, so when you do that, you have, so like you make equal signs and just give them away.
Exactly. Yeah. A WebAssign is only as smart as the person who programmed it. So probably not a full math teacher, probably not a full programmer, right? So somewhere in between. Nothing's perfect. You just get used to it. The reason why I don't count WebAssign as homework, because you could just cheat on it. Well, you could cheat on everything, but it's really easy to use Photomath and just take a photo of the problem and it gives you the answer and just type it in, right? I'm trying to get you to learn, trying to get you to be the top student, right? So we want to make sure we can understand everything and do everything. And then it's all about writing. It's really all about how you're writing things down, how you're communicating to me, and you can't do that through WebAssign. I can't see what all your steps you took, right? So that's why I want you to hand in homework. And again, once I assign homework, you know, all those problems I just gave you from 2-1 to 2-3, you can do them in your head, on a bar napkin, on the mirror in the bathroom with a white erase pen, or on the window, right? Anywhere, I don't care. But when you're going to turn the problems in, it might take you 2 pages to do the problem, then you want to rewrite it and get it to 1 page, right? Does that make sense? Don't hand me a homework problem with a bunch of things crossed out in it, right? I want it to read perfectly. All right, 3 times a limit fails to exist, and they are a jump discontinuity, continuity should be obvious. Something that's continuous has got like a nice little roller coaster ride, right? No holes in the track, right? So discontinuity, there's a hole, but it's bigger than just a point, because what do I care about? Just a single point removed? Do I care about a single point removed to get a limit? No, because? Say again? I want something with the notation I have here. X should never get to what? C. X never gets to C. So I don't care about whether the point there is there or not. All I care about is, can I guess the height as I'm going down? Can I guess the height as I'm going down? Do they match up? So this is not a jump discontinuity, this is just a discontinuity. So this is a discontinuity with a limit, and this is my jump discontinuity. There's the jump, right? You see it? So, right, as I'm walking here, my height is negative. As I'm walking here, my height is positive. There's no way they're meeting up. You can see my epsilon delta, and don't let me scare you with this. I'm not going to test you on epsilon delta, but I want you to understand the epsilon delta. Do you understand that if I can guarantee myself to hit the dartboard, and then even when I shrink it down, I still guarantee to hit the dartboard, guarantee to hit the dartboard, guarantee to hit the dartboard, I get the limit. If I'm always guaranteed to get the dartboard and the dartboard goes to 0, then the arrow's got to be right there on the center, right? So look at this jump discontinuity. What is my formal definition? Anybody have it? The very first symbol. What does that mean? Good. For every epsilon, for every single number bigger than 0, for every single white bullseye board I have out there, no matter what size it is, if I can hit the board, I'll guarantee eventually I'll get the limit. So that means what? Every epsilon. So even this epsilon, that epsilon, right? There's my epsilon right there, yes? I've got to be able to find a delta. So let's say here to here, that contains the function still. But the function inside of that red is already off the board. Look at that. The pieces of the function where I shot the arrow are already off the board. The board is smaller than the gap. But it says I should be able to do this for every epsilon. So this one is obviously on hand. Right? Because now that I got my epsilon, I found my delta, I see the pieces of delta on the function where my arrows hit are off the board. So as I continue to shrink the board, did I get to the bullseye? No. So a jump discontinuity. The second one is an unbounded function. Sorry, unbounded function. So I said the limit as x goes to 0 of 1 over x squared does not exist. Now, what's happening to these lines as x is closer to 0? What's happening to these lines? They're getting closer and closer to what? The axis? Yeah, the height's going to infinity, but the lines are getting closer and closer to the y-axis, right? And so what I'm saying is, no matter what epsilon I draw, or where I draw it, right? If I pick some bullseye, eventually, right? You see that I have pieces of the function that are no longer on the target. That means there's no limit. Because remember, I said for every epsilon, so I'm going to shrink it to 0, there's definitely pieces of the function that are not on the target. So I missed the bullseye and shot it way up in the air, right? Last one is an oscillation. The coolest example of this, well, the simplest example of it is that light with the string, right? On and off and on and off, right? What about sine? What function oscillates? Well, the trig, sine, right? Look at sine function. Where does it go in between? Nice, -1 and 1, forever, right? So when I get all the way to the end, what is it? Don't know. Don't know. Right? So it's oscillating. The interesting one that's oscillating is the limit as x goes to 0 of sine of 1 over x. And this one is a DNE. On Desmos, this is really easy to see. On a calculator, it's not so easy. So I just want to graph. Yeah, sine of 1 over x. And so I am expanding, right, just dragging, right? Right, just dragging that way, but look how dense it is inside, right? You can't even tell that it's actually looking like this, but it's so pushed together, right? But say again? Oh, okay, good. So it's so dense, right? And I guess we would say 0, right? Because you can see that it's constantly going back and forth to 0, right? Between -1 and 1. But when I draw my epsilon on here, when I draw my target, can I draw on here or with what? Can I draw? How do I draw on here? I should be able to draw on here. I thought I could draw. No, I don't want to do that. Oh, maybe I can do this. Nice, download the PNG. On downloads, fine. So I'm going to go into my OneNote here and import an image. Where is it? Pictures. From file. From downloads. Desmos graph. Open. Nice. If I draw on here an epsilon, like here, right? Even if I pick the smallest possible delta, Do you see that there's points of the curve within that delta that are not on the board? Yes. So it doesn't exist. And this is an interesting one to do numerically. I'll ask you to do this numerically. Right? Do this one on your own, numerically. See what happens when you put in 0.1, 0.01, 0.001, 0.0001, etc. You're going to see something interesting. And then I'd ask you to kind of think about, okay, do you think it's going somewhere? And then keep going. 0.00001, 0.000000001. Keep going. And you'll see that you'll never get things to match up. So you're never getting not the same side to match up the right thing. Right? Nice. All right, here we go. Section 2.1. This is the secant tangent problem. Pretty noisy when you read it in the book, but if you start to read it again now that I'm doing this, it might make a little bit more sense, okay? So I want to kind of look at the general problem we've had in the past, right? So I'll say something like this, where I have my first x and my second x, right? And so here I have x sub 1, y sub 1, right? X sub 2, y sub 2. Yes, you with me? And if I draw that line between there, that guy's called the secant line. If you remember from high school geometry, the secant line would go through 2 points of a circle. A tangent line would only hit 1 point of a circle, right? And it's the same thing here. We're doing secants and tangents. So the secant line, and I missed a little bit, sorry. Right, I'm trying to go through both points here. There we go. Right, so there's my secant line. What I'm really interested in, though, is my tangent line. So the tangent line is only hitting that 1 point of the circle. I like to think of skiing, even though I'm not a skier. But if I think of myself as a skier, and I'm definitely on a bunny slope here. I don't know if you know skiing at all, but I got my headphones on, right? So I'm skiing, and we're really saying my center of gravity is at 1 point. So I'm standing on the hill there, and my skis are there, right? And I'm frozen, let's say, not moving. I want to be able to calculate the slope of the skis at any 1 point, right? Does that make sense at all? Everybody understand skiing? Snowboarding? Yes? You know, you're with me? Skateboarding? Anything like that? Yes? So, secant line, easy to get. In fact, we did get the slopes of our secant line in pre-calc. What did we use? What was it called? What was that concept for us in pre-calculus where we got the slope of a secant line? Got two initials, B and Q, not about ice cream. B and Q, remember that? Pre-calc? Yeah, B, Q. No one remembers the pre-calc calculating the slope of the secant line? Come on. No way. That's all I did in pre-calc. When I teach pre-calc, I do that in every chapter. You don't remember doing the slope of a secant line in pre-calc. Do you remember something called the difference quotient? That's the slope of a secant line, difference quotient. So, the difference quotient I'll call it M, which is the slope of the secant line is f of x2 minus f of x1 over x2 minus x1. Do you remember it now? Oh, this is slope, right? y2 minus y1 over x2 minus x1, right? Okay, but we're going to change it a little bit. What we're going to do is instead of calling, using subscripts, we're going to just say that the first point is x. So I have x comma f of x as my coordinate, right? And the second point is x plus h. So my point there at that one is x plus h comma f of x plus h. And then what is this distance? H, nice. So take a look at my slope here, my difference quotient. By the way, the difference is f of x plus h minus f of x. That's the difference, yes? Fraction bar, that's the quotient, difference quotient. And what do I get downstairs? I get x plus h minus x. So that simplifies to what? H only, good. So these two pieces are saying exactly the same thing. What I want to happen is I want to be able to do a bunch of secant lines and get the limit. Right? So I want a bunch of secant lines. There's my first one. There's my second one. There's my third one. And the fourth one is exactly my tangent. Right? So I'm gonna, what am I doing to the 2 points here? Exactly. Exactly. In the first one, I'm getting x2 to go to x1. In the second one, I'm getting x2 to go to x1 by letting h go to what? Yes. Yes. So you can already see we're going to be doing limits of this as h is going to 0. What's going to happen to my secant line is going to become my tangent line, and now I can use the limit to predict the slope of the tangent line. Desmos, ready? We're going to put an arbitrary point. If I call a point x for Desmos, it's going to give me every x. Okay? So what I have to do is give it a letter name. So I'm going to call it A. Oh, I better get a function here first. Let's just use something simple like x squared. F of x equals square root of x. I already know my domain. X is greater than or equal to 0, right? I know the range. I know all of this from pre-cal, right? But I want to put an arbitrary point on here, and I'm going to use the letter A. You can use any letter you want. If you use pi, it won't work. If you use E, it won't work. So I'll use the letter A as a variable. So A comma f of A. And it says add slider A. I click on it to say yes. So now I can move this here. I can move this arbitrary point here, right? Oops, can't be negative. Or I could go onto the curve and move it, right? You see? Everybody able to do that? Good. Okay. I want to put a second point on using my new notation, which is A plus H, X plus H, right? Yes, you with me? So I'm putting on a second point, a plus h, comma, f of a plus h. And now I have a new slider, h. So again, I can use h, right, to move, or I can just use the mouse to move, right? But notice, once I have h set, if I now move a, what happens to the people? They stay the same distance apart, right? You see that? If I have my h fixed, and then I move my first point a, I'm going to keep that distance h the same the whole time. Now, what do I want here? What do I want to do now? No, not another letter. And put the secant line in. Let's put the secant line in. So let's do a little work before we type it in, okay? Is everybody here with me now at this point? Everyone has this on the screen? Some of you are either just not looking at me or don't want to talk to me today. It's fine, I don't care. Everyone okay? All right, I want to put the secant line on. It's going to take me a little bit of work. Yes, question? Squirt. S-Q-R-T. S-Q-R-T. And then it will ask you to turn it. Yeah, right. Yep, anybody else? You'll see I'll write pi, y, I'll write integral int, I'll write derivative d dx. You'll see it. Yes, it gives you a function. It looks right away like the square root of x, right? There's a little library of functions in there. Is that right? What's that? Don't make it negative. Yeah, okay. That's another point. All right, what do we need for a secant line? I need a slope, right? I need a slope, and I need at least one point, right? I need a point slope form. Yes, who remembers the point slope form from Algebra 2, from pre-cal? Point slope form, what is it? It's y minus y 1 equals m times x minus x1, right? So x1, y1 is a point. M is the slope. And x and y are variables. So xy stands for every point on the line. x1, y1 is a specific point on the line, right? And slope, of course, is calculated with 2 points, right? Nice. What's our slope? F of x plus h minus f of x all over h. For us, it's going to be, and this is the slope of the secant, right? It's going to be f of a plus h minus f of a all over h. So I like to just do a quick calculation of this as m. I think this works. I forget. Let me try it first before you do it, okay? Let's see if I can get an m equal to f of a plus h minus f of a oops. Yep, it's going to work. All divided by h. There's my slope. It's kind of nice because as I let h go to 0, my slope is right. My slope's changing, right? Okay, I'm ready for my secant line. What is it? Y minus what? F of A, right? Equals m times what? X minus what? Nope. Nope. You said H twice, right? Yeah, nope, nope, and nope. X minus what? X minus what? Nope. Nope. Yes, x1, yes. So what? A. Right? So for us, it's y minus f of A equals m times x minus A. Oops, missed it by that much. There's my secant line. If I were to draw, yeah, we're not going to. We're going to use this one secant line, right? And we're going to move the H closer, and we're going to try and guess at the slope, right? When H goes to 0. We're going to try and guess at the slope when H goes to 0. Let me use a different function here, okay? Let me use a different function here. Let me change to x squared. So you can just go to your f of x and just use x to the power of 2, right? And I'd like to set a at 0. And I'd like h to get there by 0.01s. No, let me change that. Let me go from -1 to 1 by a step of 0.01. That's what I want. So I set, I want H to get to 0 quickly, right? Like even if you remember me doing this in our limits already, I said 0.9, 0.09, 0.009, right? Or I'm sorry, other way. 0.9, 0.99, 0.999. See, I'm getting to 0 really quickly, right? So I just want to, and I just chose this arbitrarily, okay? So bear with me, play around with it, right? So there I am. I'm trying to predict the tangent line at 0. So A is going to stay fixed first. In the homework in 2.1, A is fixed, okay? But the other point is arbitrary. So I'm trying to predict what happens, right? What happens when H goes to 0? So I'm looking at my slope there. Where do you think it's going? Yeah, to what slope though? Look at my m value. To what slope am I getting closer and closer to? 0, exactly. And even if I go from the other side, when I get when H is 0, there is no line anymore. But that will be the slope of the tangent line. Should I let H get to 0? No, I can't. But I predict what would happen if H got to 0. That's a limit, right? So here comes our important piece of information, and then we'll do a problem, okay? I know it's boring as hell. The limit as h goes to 0 of the secant slope is the tangent slope, or the slope of the tangent line. So the limit as h goes to 0 of f of x plus h minus f of x all over h, it gives us f prime of x, which is the slope of the tangent line. How are we doing? Anybody completely confused, lost, anything? I'm the dentist. You can't lie to me. Which tooth is it? You just keep shaking your head no. I'm just going to start drilling because that's what I like to do. Yeah. Stop. Yes. Stop. More. Yep. Zoom. You want me to zoom somewhere? Let me put numbers on. Okay. 1, 2, 3, 4, 5, 6. Which one do you want me to zoom? 5? One more? Yeah. Yep. So here I'm talking about my point slope form, right? Point slope form should go on your formula sheet. Yes? You know how to do the equation of the secant line right now. You're eventually going to learn the equation of a tangent line. Secant line is pretty damn easy. What do I need for the secant line? 1 point and a slope, right? Yes, but yeah. The same, yeah. So remember, this is 2 points on the curve, right? So the function is the curve, the secant line is a straight line through 2 points on the curve. And yeah, so exactly. So we're going to use the secant right now just to predict the tangent slope. But so a equals 0, that correct. Yes, yes. But you'll see, we're not going to let h get to 0, right? Remember my limit. If h goes to 0, do I ever get to 0? No. Right? As x goes to c, do I ever get to c? No. Right? So what we're going to do is we're trying to predict the slope at that one point. And if I look at my x squared function, say again? Yes, let me come right back to it. But at 0, can you see me standing on that hill on my skis? And what's the slope of the skis then? So you see, I can use the secant line to predict the tangent slope. Abigail, what line? Number 6? Yep. So what did I do in 6 is I replaced the x with my first point. Right? Originally it was an x sub 1. And then because decimals doesn't understand x sub 1, it understands a. So I can put in an a there. Line 7. Yeah, so line 7, I'm saying as those 2 points get closer together, right, I can see what's going to happen when they get exactly on top of each other, right? So right now we don't know this yet. We're learning about this right now, right? We're learning. Anybody know the name of this guy? What's the function that represents the tangent slope? Begins with a D. Derivative. You heard that before? A derivative function? Derivative function? Get the slope at any single point on the curve. Right? So we're going to call this derivative f prime of x, which is the slope of the tangent line at any point on the curve. All right, here we go. How much time do I have? No time. So I'll have to finish this next time, but it's not a big deal. No rush. You have plenty to work on this weekend, yes? I'm available this weekend. I'm playing golf today. Might play golf Monday, but in between holes, if I'm waiting, I can answer an email.